as you can see, I've already worked out the last example in this section, and it uses the quotient rule because there are x's on the numerator and x's in the denominator. So after you figure out who's first and who's second, you have to differentiate, and the interesting part here is that the chain rule comes into play when you're finding the derivative of second. The derivative of 3x plus 2 to the power 4 is going to be 4 on the front, and then the 3x plus 2 to the power 3 with the derivative inside, which is 3. Whereas the derivative first does not require a chain rule, it's just a simple power rule. So once you do that, you're going to have to set it up with the quotient rule and multiply the opposite corners, and I did that on the first line. Now notice how I circled the 2 down here. That's because the quotient rule says square whatever your old denominator was, and my old denominator was 3x plus 2 to the power 4. So now I have some sort of a double power situation. And the rule says when you have a double power situation, you just multiply the exponents. So, 4 times 2 is going to be the 8 that you see on the line. I also saw that there was a 3 and 4 right there in green, and I turned it into a 12. That's all I did on that line of the question. So everything else I just copied literally word for word, term for term. And I just swapped the 2 parentheses there just for kicks and giggles. Now, once I get that done, I look at the first term as one single term, the second term as one single term, and all of that right there as one single term. And I'm asking myself, what is repeating in all of them? And what's repeating in all of them is the term 3x plus 2 to the power of 3. So 3x plus 2 to the power of 3 is repeating 3 times in the second term, 4 times in the first term, and 8 times on the bottom. So what I did is I canceled 3 out of each one of those terms. So the 4, cancel 3 out of it, you're left with a 1. The 3x plus 2 to the power of 3 is gone completely because you canceled it. And then down here there was an 8, but you took away 3, so you're left with 5. And that's what happened on that particular step. And that's just to help me simplify the expression a little bit better. Once I did that, it was pretty straightforward from that on. So multiply the 2x, multiply the negative 12, combine some like terms, and you're basically finished with the question. So I hope that made sense. And again, these are kind of sophisticated and challenging problems because we're combining multiple rules together. And, not every problem is going to be like this, but if you saw a problem where you have to use multiple rules, don't freak out. It's just natural. It happens in math.